Welcome friends once again to the session of marketing research and analysis. In our previous session we had discussed about one of the most important techniques of testing a hypothesis, in which we had covered the analysis of variance. Analysis of variance becomes is highly utilized in all kind of studies, basically, be it experimental or non-experimental or partially experimental, whatever it is. So, it has a lot of utility and it helps you to study among variables which are both categorical as well as continuous, right. But what if suppose you have a situation where there are data in which only, let us say, categorical data are available, nominal data are only available, or ordinal data are only available, right. So, if the data is only nominal and ordinal, we generally have a tendency to I have seen with students and others to say only percentage. So, 40% people this, 50% people, and they leave it there, right, the research. So, the question is there a way that we can use this type of any technique which can help us in analyzing data when it is in only a non-metric nature, right. So, let us say in fact the technique now we are going to discuss is basically one of the most utilized techniques in marketing research. In fact, one of the estimates had said that around 90% of the researchers in marketing research use this technique that we are going to discuss right now. So, what is this technique we are going to discuss? So, it is nothing but called the cross tabulation, right. So, cross tabulation is nothing in a tabular format you put in the data and see how what is their pattern, okay, right. So, and chi-square test being one of the cross tabulation is a part of the cross tabulation only. It is a test, it is a very powerful test which is used in almost most of the studies where it helps you to make a statistical hypothesis testing, right, which was earlier which if one does not know this, then he would not be able to do a hypothesis testing with nominal data or ordinal data, right. So, this has a very large importance. Okay, let us go slowly to this study. So, what is saying cross tabulation is a statistical tool that is used to analyze categorical data. Here categorical data are variables data or variables that are separated into different categories or which are different from each other, mutually exclusive from one another. Let us say one of the categorical data is eye color. So, your eye color can be divided into, let us say, blue, brown, green, black, okay, which is normally let us say black, and it is impossible for one eye color to belong to more than one category. So, that is why it is called categorical. It can be staying in only one category, and very seldom, very rare events. If it is in two categories, then that is no more a nominal, rather it becomes a category ordinal data, maybe it can fall into two groups, right. So, in the earlier case, as I said, t-test and ANOVA, we were determining a relationship between a nominal variable and a continuous variable, right. But what if we are interested in the two nominal variables, right. Example, class and unemployment, right, gender and drug use, let us say the city and the liking of which city you come from and which player do you like in a particular football team or a cricket team, right, or which city favors which team, okay. So, or let us say which gender, what gender likes what kind of TV programs. So, there are studies which might not be always, the data might not be continuous in nature, right. So, continuous is one thing, but what if what if the data is both in nominal, right, as I was saying. So, let us say, as I said, let us say the data is, you want to find out a relationship between, let us say, gender, which is categorical, let us say only male and female, and let us say the kind of TV program. Let us say TV program could be soap, dramas, right, or sports, okay, or reality shows, okay. So, whatever, now is there a relationship? Suppose a manager can know about this thing, then automatically it can be of great use to him or her by creating better policies, better plans accordingly for the market, okay. So, cross tabulation uses nominal or ordinal variables, right. It is a tool to descriptively examine variables, right. Tools, it uses tools to identify whether there is a relationship between two variables. So, basically it is sometimes it is also called a test of independence, right. We will see each one of them. So, what is a bivariate cross tabulation? That means bivariate, two variables, starts with two nominal variables in a data set. Example, gender and political party. So, this is the example I have brought. So, let us say gender, male, female, and political party could be, let us say we have two political parties SP, BSP, right. So, cross tabulation is simply counting up the number of people in each combined category. How many SP women, how many SP men, BSP women, BSP men, right. It is similar to computing frequencies, but let us see, but earlier when you are doing a frequency, generally about 90% of students do, they only create a pie chart or an histogram, show the frequency and that is all, right. But for two variables jointly rather than just one. So, let us see this. So, let us say female is equal to 1 and SP is equal to 1, right, the out of the two parties SP. Now, this is a this is how the data looks like. It looks like something like a dummy coding, right. So, 0 1 1 0 0 1 1 0 1 0. So, this is how you have got the data, for example. Now, the question comes to you, how many BSP women are there in the party or in the data set? Now, what is BSP? Now, SP is equal to 1. So, BSP is equal to 0. So, 0, okay, 0 0 0 0. So, are these all zeros women? Now, let us see. Now, woman was 1. So, 0 1, okay, 1. This is 0, but this is 0. So, he is a male, right, not possible. 0 0 not possible, 0 1. So, there are 2, right. So, these 2, answer is 2, okay. Now, this is another, this is, let us say this is a breakup given. So, let us say there are 43 women and 25 men, of which 43 women are into 27 are into SP, 16 into BSP, 25 men, 10 is for SP and 15 is for BSP. Let us say this is the breakup, okay. So, how does a table, joint table look like? So, it is also called a contingency table, please remember. So, SP woman, SP men, BSP woman, BSP men, okay. So, 27, 10, 16, 15, okay. So, this is each box with a value is called a cell, please remember, right. And what is the total now? This is a okay. This is a table row, right? This is a table, and this is a column. So, this is the column. So, these are the these are two rows and two columns, okay. Now, look at this, what it is saying. So, 27 plus 10. So, SP has got total 37, okay. 27 women, 10 men. So, total 37. BSP has got 16 women and 15 men. So, 31. So, total SP is 37, total BSP is 31, total women is 33, total men is 25. So, when the data is in such a format, it is very helpful for the market researchers, okay. So, now let us, so this is the column and the row and the column total, okay, okay, and this is the entire grand total. So, the grand total is 37 plus 31, 68, or you move from this side, it is the same 68, okay. Now, if you now find the percentage, now let us say this was 27, so 27 was what percentage of the total? Now 27 divided by 68, so 39.7%, 14.7%. So, from this one can say ki what is the percentage of women who are in, what is the percentage of whether men are more in SP or women are more in SP, let us say, and similarly for BSP. Now, we can easily say that more women are there in SP, and in case of BSP also it is women only, right. It is women only, but men are pretty higher in the case of BSP than SP, right. So, although this is less, but this difference among these two is not very high, right, but this difference is very high. That means, SP now has to try to get in more men than women, right, okay. So, this is we discussed, okay. Now, how can we tell if there is a relationship between the two variables? Now, the question is, till now we have discussed only from the frequency by an observation. We said ki this is what is the data. Now, this from this percentage we can say ki what can be done, right. But the question comes here, can we tell that there is a relationship between the two variables, okay. Now, let us see, if category on one variable appears to be linked to the category of other, right. Now let us check this. Now this is the case, now 43, 25, right. So total is 68, right. Now if there is no relationship between the two variables, they are said to be independent. So many a times we say it is a test of independence, right. So neither depends on the other, that means if there is a relationship, the variables are said to be associated or to co-vary. So chi-square test works as a test of independence also, it works as a test of association also, right. If individuals in one category also consistently fall in another, that means a person is woman is equal to SP and men is equal to BSc, you may suspect that there is a relationship between the two variables. That means what it is saying, if individuals in one category also consistently fall in another, that means they are visible in both the places, then there is a relationship between the two variables, right. Now cross tabulation, it says relationships are always not very clearly visible, right. So widely differing numbers of people in categories make comparisons very difficult. Example, if there are 200 men and only 15 women, the comparison would have been very tough to do, right. Now you have done this through let us say we have gone through it. So we have calculated the percentage and we will see whether the tests are independent or not. So and we thought from the value this is they are not dependent and there is a clear distinction, so they are independent of each other, okay. Now to test whether the relationships actually exist or not, is there a significant relationship or not, just looking at a value will not help us. So we need to have some hypothesis, some statistical test for it. So the statistical test which we use is called chi-square. Chi-square test is nothing but a test used for the cross tabulation or the data in the cross tabulation, and it helps you in finding out whether there is any significant relationship between the variables or not, okay. Now what is it saying? So if you look at it, chi-square is denoted like this, is symbol is equal to, it says observed frequency minus expected frequency divided a square upon expected frequency. So this is the actually formula, right. So okay. So this is the chi-square formula I have given. Now how do you calculate this expressed frequency? Now what is this? Let us take this example I am now doing. Let us say I want to see whether there is any relationship between, let us say, income level and cleanliness, okay. High income, middle income, low income, okay, and I have cleanliness very clean, moderately clean and less clean, okay. Now I have got some observations, I have made some observations, and let us say this is 10, this is 12, this is 15, this is 12, this is 17, this is let us say 11, this is I am randomly putting numbers, this is 13, this is 18, this is 12. So can I say that there is a relationship between income and cleanliness? Can I say that? Now these are my observed data, right. Now if you see this formula, I need an observed and the expected frequency. So what is the expected frequency? That is what it is saying. The expected frequency is equal to, you have to go through the total. Now 10, 20, 30, 33, 35, 10, 20, 30, 38, 45, 47, okay. I hope my additions are all correct. 30, 32, 35, 36, 38, okay. Similarly you can add this side. So this you have to add the column total, right, and these are the row total, right. So row 2, row 3. So now expected frequency is equal to row total for that, right, into for that variable. Let us say you are talking about this variable. So R1, it will be R1. So let me write this first, row total and column total by grand total, okay. So in this case let us add this 10, 20, 30, 35, 37, okay, this is 37, this is 10, 20, 30, 37, 38, 40, okay, this is 10, 20, 30, 32, 30, 43, okay. So what is my first value, observed expected value? Now 35 into 35 this into 37, right, upon how much total you have to add up this 3 30 40 70 30 100 108 115 120 120. So, similarly you have to find out the expected frequency for each cell. So, this one, then next this one. So, for this one, this into this divided by grand total, right, 120. For similarly this you have to count, right. Now, after doing this, so what it says to let us say and what is one important thing that in a when you do this, you also have to know what is my degree of freedom, because at the end of the day when you want to after you have calculated the chi-square value, the chi-square value has to be compared against the table value, right, for a certain degree number of degrees of freedom. So, what is the degree of freedom? Now, rho into 1 rho minus 1 into column minus 1, I hope this is you can see this degree of freedom is equal to r minus 1 into column minus 1. In this case, in our this case, how many rows were there? Now 3 minus into 1 minus of 1 into how many columns? Now 3. So, how many so what is my total degree of freedom? So, this is equal to 4, 2 into 2. Okay. So, the null hypothesis in this case is no association between the two variables is there. So, there is null hypothesis says there is no association, right. Okay. Now, let us see this. So, this is exactly the chi-square will not look like, the chi-square will look slightly different, I will show you, but anyway. So, where does it fall? We will see that. Okay. So, the let us say in this example, in the sample women appear to be more in SP and men with BSP, I think it is what it is saying. How do we know if this difference is merely due to sampling variability? The question is that is this difference of men and women that you saw, that we also were speaking through a cross tabulation, is this just due to the sample, or actually it is a way, it is actually in the population also it is the same thing. So, let us do this. To do this, we say the chi-square test is to be used, right. So, it is a test of independence. It asks if there is a relationship between the variables or not, right. So, independence means there should be no relationship, they are independent of each other, right. So, what is my null hypothesis? The gender and political party are independent of each other, that means there is no relationship between gender and the political party. In this case, there is no relationship between the income and the cleanliness of people, right. So, alternate hypothesis, they are not independent, as good as that. Now, observed value and the expected value, I was just telling you, right. So, expected value is, as I said, so you have to find out this I, the value for the I, that means the column row total into column total and divided by the overall total, grand total. Okay. Okay. So, let us say this now look at this case, right. So, we have got these values. Okay. Now, for example, this one, now how it is done? Now, 37, so this is 37 into 25 divided by 68. Okay. So, this is 13.6. So, this value for the expected one comes to 13.6. Okay. For let us say this one, now this will be and each one you can see 31 into 25. So, this for this one this cell is 31, the row total into the column total is 25 divided by 68. If you multiply, this will come this much. So, all the cells have been multiplied, this is only an example which has been shown. Okay. So, the chi-square test of independence basically it helps in comparing the expected and the observed values, right. So, if you what does it basically compute? Now, it says the expected minus observed square upon the expected. So, in books you will find it is written observed minus expected, it does not matter because after all there is a square. So, the sign will not matter to us, right. So, upon the expected. Okay. So, in basis of this, so what we do is finally we will reject or accept our null hypothesis. Okay. So, now in this case let us say once we had the observed values of 27, 10, right, 16 and 15, right. Next we calculated, as I had said earlier, how did we calculate? Now, we did the row total into column total divided by the overall total, right, overall total, or which is also sometimes n also, the total n, right. So, by doing this we calculated the E11 is equal to 23.4, E12 is 13.6, E21 is 19.6 and E22 is 11.4. Okay. Now, once we have calculated this, from here we will calculate the expected minus observed square, that formula. So, again as I said, I generally have a habit of writing observed minus expected square divided by expected. So, this is important because anyway the square will take care of the other things, right. So, by doing this we found that in SP women it was the E minus O square upon E, the overall chi-square value came to 0.55 and for men it came to 0.95. For BSP the woman it came to the chi-square value was 0.66 and this is 0.86. So, the overall chi-square value is equal to, overall chi-square value is added up here which came to 3.02. Okay. Now, what are we going to understand from this value, right. So, as now you have to understand that when you have the calculated value you have to obviously compare, like any hypothesis testing we have done it till now. So, we have to compare it against the critical value or the table value, right. So, if that is this is how it looks like. So, and our value is somewhere, let us assume this is 3.02, right, 3.02. So, what is the critical value now? So, to check the critical value first you need the degrees of freedom, as I had said I think. So, degrees of freedom is calculated as R minus 1 into C minus 1. So, in this case we had 2 rows and 2 columns. So, that means 2 minus 1 into 2 minus 1 is equal to 1, right. So, the critical value, let us go at a 5% level. So, if you look at this table and then you go to 0.05, 5% is what you wanted, right. So, when p value is 0.05, right, and your degree of freedom is only 1. So, you have a 3.841, correct. So, now you can compare it against this and you can find out whether you have to accept or reject. So, our value was less 3.02. So, that means we cannot conclude at this moment that there is a relationship between gender and political party affiliation. Let us have a problem which I had brought for you. We will do this. So, this problem is something like this, right. It says this says there are 200 people, okay, randomly selected adults. They were asked about the TV shows, their opinion, right. Both male and female were asked what do they feel about the TV shows, right, whether the TV shows are only having an entertainment value, they are having a educational value, or it is just a waste of time. Okay. So, the broadcaster, they wanted to find out whether any relationship exists between to suggest that there is a relationship between gender and the TV the opinion about the TV serials. So, to do this let us solve this problem out here, right. You can continue with me side by side when I am giving the data. So, let us say there were female and male, right. Now, who thought entertaining is of this entertaining, some thought this is educational, some thought it is a waste of time. So, 52 women thought it is entertaining, 28 men thought it is entertaining, 28 thought it is educational, women thought, and in male 12 male thought it is educational. In waste of time 30 women thought it is a waste of time, 50 men thought it is a waste of time, right. So, now let us see if let us solve this. Okay. So, first in the first step what we have to do is we have to find the column total and the row total. Let us see the column total. So, the column total I have brought it already. So, 80 this is 40, this is 80, okay, and this side if you go to the row totals it is 110, this is 90. Okay. So, the overall total or the which you say the n basically is how much? Now, 110 plus 90, 200, right. So, you go through this way or that way, right. So, now let us calculate. How do we calculate? Now, we have the observed values with us now, we have the expected values with us. Now, let us find the observed minus expected square, right, upon the expected. So, this is my chi-square. So, chi-square is equal to so this, right. So, when I am writing this 52, 28, 30, 28, 12 and 50, okay. 44 we calculated this. So, have we calculated? No, we have not calculated, sorry, I have brought, so I am saying. So, let us calculate the expected values. So, for this one 110, let us say for this one 110 into how much? Now 80, okay, upon the grand total which was 200. So, this was this 2, 4, 11, 4, 44. So, this comes 44, okay. Similarly, for this one 110 into 40. So, 110 into 40 upon 200. So, 200, so 2, 2, 2, so 22. So, similarly we can calculate for the others, right. So, when I am calculating for the others, I have already done it. So, I am writing it here 44, this is 36, this is 18, and finally this is 36. So, these values only I have now I am writing out here. So, 22, 44, okay, 36, 18 and 36, and from here let us finally calculate the chi-square value. So, 1.4454, sorry, this is 1.636, right, 4.455, 1.777, 2.000 and 5.444. So, if we take the overall total, it is coming something around 16.76, okay. So, now this is our overall total. Now, what is now we have to calculate it against the table value. So, the table value critical value is now we have to find from the degrees of freedom. So, what is our degrees of freedom in this case? Now, there are 3 columns, okay. So, 3 columns minus 1 into 2 rows minus 1. So, that means what we have got 2, right. So, we will have to find the value for 2 degrees of freedom, right, and let us check how much it is coming. So, for 2 degrees of freedom at a 5% level of significance, the value is how much? Now, 2 degrees of freedom, okay, and 5% level of significance. So, 5.991. So, if it is 5.991, so that means how where will I draw? 5.991 is the cutoff value, 5.991, and we have got a value of 16.7, which is far beyond the critical value, right. So, that means what? Our null hypothesis is rejected, and what was our null hypothesis? That the gender and the opinion about the programs is independent of each other, right. So, if you go back, let us see this, as you had here gender and political party affiliation, right. There is no relationship between gender and political party affiliation. Similarly, in this case, in this case, it is becoming there is no relationship between gender and the opinion about the programs, right. But in this case, it was we could not conclude, the null hypothesis had been accepted, but in the case which we have solved here, we are saying that the null hypothesis is rejected. That means there is a significant difference between what females feel and what males feel, right. So, this is how you calculate the chi-square value and you test an hypothesis through the chi-square, right. 2 things I am going to show you here besides this. These are some of the values which you will see, these are called a phi coefficient, which is used in case of any software. If you are using any SPSS or something, you will see this, and sometimes people get confused to understand what does it actually imply, right. So, the phi coefficient is nothing but it is the root over of chi-square value by n, right. So, what it basically does is it helps in measuring the strength of association between 2 variables, right. So, between 2 variables like in any test, right. So, the phi coefficient when it is close to 1, when it is 0 there is no association, and when it is close to 1 we will feel that they are perfectly associated. There is a high degree of association between the 2 variables, okay. One more variable, one more data that you see is called the contingency coefficient, right. So, this is shown as C, which is nothing but a chi-square by chi-square plus n, right, root over of that. So, it varies again between 0 and 1. The maximum value of the contingency coefficient, why I am saying this is you might require it to write down during a research paper. It depends on the size of the table, okay. the number of rows and number of columns, right, because that is the n basically, right. For this reason it is to be used only to compare tables of the same size. If you have tables of different sizes, then you should not or you cannot compare it, right. So, this is one thing, and one last thing which I had forgotten is you have to remember that when you do a chi-square test, please remember that your cell values have to be at least 5 or more than 5, right, otherwise it does not give a it is not wise to use chi-square test. So, this is all about the cross tabulation and chi-square test, and I hope you have understood why it is used. It is a very simple but very powerful technique which is used to used when you have nominal data, and you have in any questionnaire that you collect or something, you have lots of nominal data, right. For example, gender, religion, sometimes suppose income, for example, let us say you have income. Income is not a categorical data, income is a continuous data, but you can convert that continuous data into a categorical data. Now, how is it? For example, let us say in this case, for example, let us say you have people of income, let us say which somebody says my income is 2,60,000, somebody says mine is 3,400, let us say forget the zeros, right, 2,60,000, 3,40,000, right, somebody says 5,20,000. Now, what you can do is you can say anybody in between 1 to 3 lakh is only 1, right, anybody between 3 to 5 is 2, and anybody above 5 is 3. So, now we have converted the continuous data into a categorical data, right, and then again you can use chi-square. But yes, if you convert a continuous data to chi-square, there is no doubt that there will be a loss of information, right, but you can do it, right, if required. If you want, your research wants to get an idea ki how people are behaving in particular income groups. So, if you want to take a continuous completely all the data, it might be tough. So, it is better to convert it into a categorical data and do a chi-square test and see ki whether there is any relationship between maybe like income and, as I was showing earlier, but with my example, between like income and cleanliness, and let us say religion and spending habits. So, these are the things which you can do through a chi-square test. So, I hope you have understood, you have enjoyed the session. It is a very powerful technique which you can always use, and whenever in a questionnaire you have demographic variables, you are free to use this technique and you can get wonderful results out of it, which will be highly useful. Thanks for this session. We will meet in the next session. Thank you very much.